the modern general equilibrium theory begins in the 50s, where two distinguished economists, Kenneth Arrow and Gérard Debré, the first was an American economist, the second a French economist, wrote in 1954 a paper in which they proved for the first time the existence of equilibrium under general hypotheses, conditions about preferences of consumers, technologies of the firms, and so on. The fundamental result in general equilibrium theory, and also the proofs of existence of equilibrium, which I shall show you, are substantially based on this work by Arrow and Debré. In order to prove the existence of equilibrium, of course, these authors employed the fixed point theorem. However, since they used not simple demand and supply functions, but correspondences, in other terms, multivocal functions, they were obliged to use a generalized version of the theorem, proved by the Japanese mathematician Kakutani in 1941, while the original theorem was by the Dutch mathematician Leif Bruder in 1910. The fixed point theorem by Kakutani proved the same result as that by Bruger, but for correspondences. Debré considered the case in which the choice of a consumer or a firm is not unique. There are many optimal bundles, many optimal production processes for a consumer or for a firm. And so it was necessary to employ this generalized result. But this was only a first step in the proof of existence of equilibrium. In effect, both Debré and many other authors in the following years supposed that individual preferences are regular, as Pacini told you in the first module of this course, that at times they are representable by a preference relation which is reflexive, transitive, and complete. The usual assumption of standard textbooks. Other economists, among which is important to remember the same Mascolin, and then Schaffer, Sonnenschein, and many others, succeeded in proving the existence of a general economic equilibrium, even in the case of no regularity of preferences. I shall show the reasons for which this second proof was very much more difficult than the original one by Debré. Because when you remove regularity, the set of demanded bundles by a consumer is not, generally speaking, a convex set. You remember this case, of a constant marginal rate of substitution. This is an indifference curve. All the points in this segment are optimal points. Every point in this segment maximizes utility or preference. And it is a convex set. This is essential in order to use the fixed point theorem, the Kakutani fixed point theorems. However, if you remove regularity, even if the preferences, the household's preferences are convex, the same is not necessarily true for the demand. In other terms, the set of demanded bundles could be non-convex. This is really a problem. It is impossible to apply the fixed point theorem in the same manner as by Aaron Debray. It is necessary to reformulate the problem of existence of equilibrium by transforming it in a non-cooperative game. This is a fundamental result which emerges by these, from these works. General equilibrium can be considered as a particular case of a Nash equilibrium for an economy, an abstract economy, as these authors called it, which is obtained from the original economy by adding some fictitious agent. We shall see every particular in this alternative proof of existence. It's very important, this contribution, because they enlarged the relevance of existence proof to a more large case of preferences of the households. But there are other authors which gave an alternative proof of existence of equilibrium by not using the fixed point theorem. How was this possible? By suitable properties assumption of differentiability. In Aaron Debray, the demand and supply correspondence are not differentiable, of course. But if you suppose that the demand and the supply are single value, are function in the traditional sense, and are also differentiable, so it is possible to prove the existence of equilibrium as a limit point of a dynamic process, analogous to the traditional tâtonnement by Vargas, to which I shall made a large reference, but not exactly identical. This alternative way of proving the existence of equilibrium is due to the American mathematician Stephen Smith. It's a very important alternative way of proving the existence of equilibrium. It avoids the fixed point theorems by these differentiable properties of the demand and the supply. Finally, it is important to note that the original scheme by Aaron Debray can be generalized. There is a problem in the Aaron Debray approach, and the problem is market completeness. In other terms, the assumption that for every good, present or future or contingent goods and so on, there exists today a market in which that good can be exchanged. Clearly, this is not true in the general case. For many future goods, today, a market in which these goods can be exchanged simply does not exist. So, it is important to have an alternative version of existence of equilibrium in this more realistic case, in which for some goods there are not today the corresponding markets. By starting by a well-known contribution by John Hicks, this problem is solved by the so-called theory of temporary equilibrium. In which it is supposed that today there exist only the markets for present goods. And there exists a market in which is possible to exchange the purchasing power, the present purchasing power, the present money, with the future purchasing power, future money. A low market substantial. But it is not true that for every good there exists today a corresponding market. By using similar instruments as those employed by AdvMicro02, it is possible to prove also the existence of temporal equilibrium, in which in every period there is a recontracting. In other terms, other exchange will take place in the subsequent periods, while in the original model by AdvMicro02, all the contracts are stipulated in the present period. And so on, and so on, and so on. It is proved that general equilibrium theory is versatile, because it can be employed in many different contexts by suitably modifying the assumption of a model itself. Well, this is a very short historical introduction. Of course, in order to have a deep insight in these problems, you must follow the course of history economic thought. So, after another interval, we begin to consider some elementary cases of general economic equilibrium, which are simply the cases we will found in chapter 15 by Mascolello and others.